Have you ever gazed at the night sky and wondered, what happens when a star dies? This cosmic question leads us to the thrilling topic of supernovas. These extraordinary explosions signal the end of a star's life, but they are far from being a simple finale. In fact, just as stars are diverse, so too are their explosive endings. Yes, there are different types of supernovas, each with its own unique characteristics and outcomes. It's a stellar spectacle, isn't it? But did you know that all supernovas are not the same? Yes, you heard it right. Supernovas have categories too. In the grand cosmic theater, two main types of supernovas steal the show, Type 1 and Type 2. Type 1 supernovas are the dramatic divas of the cosmos. They originate from the thermonuclear explosion of a white dwarf star. Picture this. A white dwarf, the remnant of a low to medium mass star, siphons off matter from a companion star. As it gains more and more mass, pressure and temperature at its core rise until it reaches a critical point. And then, bang, it explodes in a brilliant display of cosmic fireworks, leaving behind no core, just an expanding shell of gas and dust. On the other hand, Type 2 supernovas are the tragic heroes of stellar evolution. These occur when a massive star, much larger than our Sun, exhausts its nuclear fuel. Without the energy to counterbalance the force of gravity, the star's core collapses under its own weight. This implosion rebounds in a spectacular explosion, leaving behind a neutron star or a black hole depending on the star's original mass. So, the cause of the explosion and the remnants left behind are key differences between Type 1 and Type 2 supernovas. Type 1 is all about thermonuclear reactions, while Type 2 is a tale of gravitational collapse. So, whether it's a white dwarf going out with a bang or a massive star collapsing under its own weight, each type of supernova has its own unique story. Let's quickly recap the fascinating supernova types we've learned about. Supernovas, in essence, are stellar explosions, but not all supernovas are created equal. There are two main types, Type 1 and Type 2. The key difference between them lies in the cause of the explosion and the remnants they leave behind. Type 1 supernovas, for instance, occur in binary star systems, a pair of stars orbiting a common center. In these systems, one star is a white dwarf, a small but incredibly dense star. This white dwarf siphons off material from its companion star. When the white dwarf accumulates too much matter and can no longer support its own weight, it explodes, resulting in a Type 1 supernova. On the other hand, Type 2 supernovas are the explosive end of a single, massive star's life. As the star exhausts its nuclear fuel, the core collapses under its own gravity, rebounding in a shockwave that triggers a massive explosion. The remnants of these explosions can form neutron stars or even black holes, the densest objects in the universe. While these types of supernovas differ greatly in terms of their origins and outcomes, they share a common role as cosmic recyclers. Supernovas distribute elements throughout space. The explosion ejects a cloud of debris containing elements like iron, nickel, and oxygen, which can then form new stars and planets. In fact, the very elements that make up our bodies and the Earth itself were once part of a supernova explosion. Moreover, the energy from supernovas can trigger the formation of new stars and galaxies. The shock waves from the explosion can compress the gas and dust in nearby nebulae, sparking the birth of new stars. Thus, supernovas play a pivotal role in shaping the universe as we know it. So, the next time you gaze at the night sky, remember, each twinkling star has its own destiny, and in death it might just create the most spectacular explosion you could ever imagine, a supernova.